Morning. Yesterday we have seen Nyquist stability criterion theory. Today let us see some on that. For the system shown in figure, sketch the Nyquist plot. Roughly, for all Nyquist plot you have to draw roughly, not on the graph sheet. You cannot draw because we have to draw at infinity. Some points we have to plot at infinity. That's why it's not possible to draw at scale. For k equal to 2, the value of k is given. Use the Nyquist criterion to determine whether the closed loop system is stable for this gain k equal to 2. Find the range of k for the system to be stable. Here, the open loop transfer function is this. Open loop transfer function g of s equal to 2 multiplied by 1 minus s upon s plus 2, s plus 3. What is P? P is open loop poles on RHS, that is equal to 0. P equal to open loop poles on the right hand side, that is equal to 0. No open loop poles on the right hand side. But we do not know Z. Z equal to, we do not know. Is there any open closed loop poles on the right hand side that we have to find? N is, we have to find number of encirclement with minus 1 plus j0. Minus 1, that is minus 1 plus j0. Encirclement. Here, this is the Nyquist contour. This is the Nyquist contour. For this Nyquist contour, it is in the clockwise. It is in considered in clockwise direction. It has 3 segments. One is C1, that is from 0 to j infinity. Omega varies from 0 to infinity, that is 0 to j infinity. Another segment is second segment, that is r e power j theta. R tends to infinity, theta varies from plus pi by 2 to minus pi by 2. Semicircle of radius infinity. Second segment. Third segment is minus j infinity to 0. So minus j infinity, that is omega varies from infinity, minus infinity to 0 minus. Here this is 0 plus. 0 plus means towards positive side. 0 minus means towards negative side. That is the meaning. This is up to 0 minus. This is up to 0 plus. Here, this Nyquist contour is in the clockwise direction. If you assume this as positive direction, if you consider the same direction of Nyquist contour, then it is positive. Same direction. N is positive if same direction as Nyquist contour. N is negative if opposite to Nyquist contour, that is anti-clockwise direction. This is clockwise direction. Therefore, Z equal to P plus N. Z equal to P plus N. Z must be 0. For the system to be stable, Z must be 0. That we have to check whether it is, whether Z is 0 or not, that we have to check. Now, we have to map this Nyquist contour on this system. Nyquist contour we have to consider. This is the Nyquist contour. that has to be mapped on 2 multiplied by 1 minus s upon s plus 2 multiplied by s plus 3. Here, p equal to 0. Therefore, n must be 0 for stable system. If p equal to 0 and n equal to 0, then automatically you will get z equal to 0. So we have to get the n equal to 0. If n equal to 0, automatically z also will be 0. Therefore, the system will be stable. If you map this on this, you will get the Nyquist, you will get the CGH plot. CGH plot, that is called a Nyquist plot. Nyquist plot you will get. Nyquist plot you will get. To do that, this Nyquist contour has 3 segments. Already I said C1, this is C2, this is C3. Let us do the mapping one by one. First, let us do the mapping for C1. Mapping for C1. Mapping for C1. That is, omega varies from 0 to infinity. 0 plus to infinity. Omega varies from 0 to infinity. What is g of s equal to k equal to 2, 1 minus omega, 1 minus omega, 1 minus s upon s plus 2, s plus 2 multiplied by s plus 3. Therefore, g of j omega equal to 2 multiplied by 1 minus j omega upon j omega plus 2 multiplied by j omega plus 3. Therefore, modulus of g of j omega equal to 2 square root of 1 plus omega square upon square root of omega square plus 4 square root of omega square plus 9. What is the angle of g of j omega? Angle of g of j omega equal to, for this, minus omega, but it is in the numerator. That's why plus tan inverse of minus omega by 1. Minus, it is in the denominator. This is in the denominator. That's why minus tan inverse of omega by 2 minus tan inverse of omega by 3. That's all. These are the 3 terms. Their angle of 2 is 0. So now it has a numerator polynomial as well as denominator polynomial. That's why we cannot draw the rough diagram by using conventional thumb rule. What is thumb rule? Thumb rule says if it is first order system, this is the Nyquist polar plot. If it is second order system, the type 0 system, second order type 0 system, this is the plot. Type 1 third order system, this is the plot. These are all we know, but we cannot apply those rules here. We cannot apply because the numerator, it must have k only. It must have k only. Then only these rules we can apply. Here it has numerator polynomial. That's why we cannot apply that rule. That's why we have to form a table and find various values. We have to form a table and we have to find various values. Omega, modulus of g of j omega, and angle of g of j omega. Omega will not be useful to plot, but it will be useful to find the modulus of j of j omega and angle of j of j omega. When omega equal to 0, if you substitute omega equal to 0 here, you will get 2 by 6. That is 1 by 3. That is 0.33. 0.33 is the magnitude. If you substitute omega equal to 3 here, omega equal to 0 here, you will get 2 by 6. That is 0.33. What is the angle? If you substitute omega equal to 0, omega equal to 0, omega equal to 0 here, the angle is 0. When when omega equal to infinity, what is the angle and magnitude? When omega equal to infinity, what you will get? You will get 0. 0 or substitute omega equal to infinity, as he said, infinity by infinity, undefined. Yes. But what is g of j omega square? That is equal to 2 1 plus omega square divided by omega square plus 4 and omega square plus 9. So if you differentiate the numerator and denominator, what you will get? 4. Yes. Thank you. 4 multiplied by 1 plus omega square. Okay. Now, infinity by infinity form, undefined. That's why differentiate the numerator and denominator with respect to omega. Before that, we have to convert this into polynomial. That is omega power 4 plus 13 omega square plus 36. So if you differentiate this, what you will get? 4 multiplied by 2 omega. Here you will get 4 omega cube plus 26 omega plus 0. Again, infinity by infinity form. That's why again differentiate the numerator denominator. 8 upon 12 omega square plus 26. So if you substitute omega equal to infinity, you will get 0. This you need not check. If numerator degree is higher than, denominator degree is higher than numerator degree, then we can put 0 immediately. Because limiting case, it will become 0. That's why this magnitude is 0. What is the angle? Angle tan inverse of minus omega is minus tan inverse of omega. That we know. Therefore, if we substitute here infinity minus 90, minus 90, minus 90. Therefore, you will get for this also, because of this minus omega, for this also it becomes minus. Therefore, minus 270. But second order system, how we got for conventional, for numerator polynomial is absent means, what is the second order polar plot? It will be like this. It ends at minus 180. But here it ends at 270 because of numerator, that too with the right hand side 0. If the left hand side means it will end at minus 90, like first order. So that's why if numerator polynomial is there, we cannot say. Similarly, if right hand side poles and 0 is there, we must be careful because the angle will be changed. So these rules we can apply only if there is no numerator polynomial, first condition. Second condition, all poles must be in the left hand side. Then only we can apply all these rules. So minus 270. You find the intermediate values here. Intermediate values here. If you find the intermediate values, here omega equal to 1, we have to find 2, 3, like that we have to find. Let us copy from there. Okay. Let us find, before finding some values, you have to find some values. It's not available. You find yourself 1, 2, 3, 10, 100, 1000, like that. 1500, like that you find. Before that, whether it crosses, where it crosses the negative real axis, that we have to find. To find that where it crosses negative real axis, then only, because the plot starts at 0.33 angle 0, and end at 270 here. end at origin at 270, minus 270. That's why it must come like this. It must come like this. These some points you can find from the table. But where it crosses the real axis, where it crosses the real axis, that we have to find. To find that, we have to consider g of j omega. G of j omega equal to 2 multiplied by 1 minus j omega upon 2 plus j omega multiplied by 3 plus j omega. Multiply the numerator and denominator by complex conjugate. If you multiply the numerator and denominator by complex conjugate, you will get in the denominator 4 square plus 1, sorry, 2 square plus 1 and 3 square, that is 4 plus 1, and here you will get 9 plus 1. In the numerator, you will get 2 multiplied by 1 minus j omega. Sorry, this is omega square, omega square. In the numerator, you will get complex conjugate of this is 2 minus j omega multiplied by 3 minus j omega. Denominator is pure real. That's why to find the point of intersection, here imaginary part equal to 0. Imaginary part equal to 0. Imaginary part equal to 0. The point of intersection here, what is the condition? Imaginary part equal to 0. That's why we are multiplying the numerator denominator by complex conjugate. Now the denominator becomes pure real, and the numerator consists of both 6. What is that? 6 minus 6 omega square plus j omega cube minus 11 omega. So this is 4 plus omega square, 9 plus omega square. So here the imaginary part equal to 0. That is omega cube minus 11 omega equal to 0. To find the point of intersection with the real part, the real axis, that is omega multiplied by omega square minus 11 equal to 0, or omega equal to, therefore omega equal to 0 comma square root of 11 plus or minus square root of 11. That is equal to 0 comma 3.3. When omega equal to 3.3, it intersect it crosses the real axis. It crosses the real axis. So what is the magnitude at omega equal to 3.3? That we have to find. Therefore, g of j omega equal to 2 multiplied by square root of 1 plus omega square divided by square root of 4 plus omega square root of 9 plus omega square, where omega equal to 3.3. If we substitute 3.3, the value is 0.4. So it intersects the real axis at 0.4. It intersects the real axis at 0.4. What is the angle? Angle 180 minus 0.4. Therefore, minus 0.4. We got only magnitude. Modulus of g of j omega only we got minus 0.4. It intersects the real axis at minus 0.4. If we substitute omega equal to here, the angle criterion, if you substitute omega equal to 3.3, you will get angle 180 degree. So minus 0.4. Minus 0.4. So we plotted for 0 to infinity. Now we have to plot the second segment. What is the second segment? Second segment is This is the second segment. This is the second segment. That segment can be mathematically defined like this. Omega equal to R limit R tends to infinity, limit, mathematically it can be defined like this. Limit R tends to infinity, R e power j theta, and theta varies from minus plus pi by 2 to minus pi by 2, or plus 90 to minus 90 degree. Here you see that here the angle is plus 90, here minus 90. The angle is here plus pi by 2, minus pi by 2. The radius is infinity. Therefore, mathematically, we can define the circle like this. Limit R tends to infinity, R e power j theta. Angle varies from. So, this semicircle can be defined as limit R tends to infinity, R e power j theta. G of j omega equal to G of j omega equal to 2 multiplied by 1 minus omega divided by 2 plus j omega multiplied by 3 plus j omega, where omega equal to R e power j theta. That is equal to 2 1 minus R e power j theta upon 2 plus j R e power j theta, 3 plus j R e power j theta. If you take R e power j theta outside, what you will get? 2 R e power j theta 1 by R e power j theta minus j whole divided by 2 plus, if you take 2 R's, therefore R square, you will get R square. E power j theta also 2 you are taking, e power j 2 theta. So 2 by R e power j theta plus j 1, that is j. Again 3 divided by R e power j theta plus j. So as R tends to infinity, here we have to put limit R tends to infinity, we have to put. While substituting, we have to put limit R tends to infinity. If you let R tends to infinity, these are all becomes 0. These 3 terms become 0. Only these 2 terms will be there. These 2 terms will be there. Then if you substitute R equal to infinity, you will get here R square. If you substitute infinity by infinity, but a limiting case, it will be 0. As a limiting case, it becomes 0 because denominator polynomial is higher than numerator polynomial. Therefore, magnitude is 0. As a limiting case, we are not going to say 0. Instead, we are going to say it is epsilon. Limit epsilon tends to 0. Epsilon tends to 0. You need not put this limit also. Epsilon tends to 0, and the angle we have to write. Angle we have to write. That is, here the angle is here 2 theta. Here theta. That's why this angle varies from j theta e power j theta multiplied by e power minus j2 theta. So we have to add the numerator, the powers. That's why you will get e power minus j theta. So the angle varies from, what is the Nyquist contour angle? Pi by 2 to minus pi by 2. If you substitute here that minus pi plus pi by 2, it becomes minus pi by 2. Therefore, theta varies from minus pi by 2 to plus pi by 2, opposite, because of this negative sign. But anyhow, epsilon is 0. Its angle varies means that point is rotating like this. That is the meaning. That point is rotating like that from minus pi by 2 to plus pi by 2. That direction is important. This point is rotating from minus pi by 2 to plus pi by 2. Like that it is rotating. But anyhow, the magnitude is 0. That's why it remains at this point. It remains at this point, but angle only varies. Therefore, always don't worry r e power, while substituting r e power j theta, magnitude is always 0 unless denominator polynomial is less than numerator polynomial. If denominator polynomial is higher than numerator polynomial, always its magnitude is 0. That's why no plot for that infinite radius. Always it is 0. Its magnitude is always 0. That's why its mapping is coming at origin only. Its mapping is coming at origin only. Now we have to map for the final segment, that is C3. If you do the mapping for C3, earlier, what is the value of omega varies from 0 to infinity, 0 plus to infinity. Now it varies from minus infinity to 0 minus. Therefore, it is nothing but mirror image of this. That's why no need to do the mapping. That's why we got this plot. So mapping of C3 is mirror image of mapping of C1 always. So what is required? Only polar plot is required. If you know the polar plot, you have to draw the mirror image of polar plot. That's all. Mirror image of polar plot, you will get Nyquist plot. So the simplest way to remember Nyquist plot is, first we have to draw the polar plot as omega varies from 0 to infinity. After drawing the polar plot, draw the mirror image of that plot, you will get Nyquist plot, unless otherwise there is no S term. If S term is there, small change is there, that we will see in the next sum. If there is no S term here, there is no S term here, S term in the denominator. If it is there, you will get one more segment that we will see in the next sum. So now we got the Nyquist plot. Nyquist plot we got, it intersects the real axis at point 0.4. Minus 1 is here. Minus 1 plus J0 is here. It doesn't encircle. Therefore, n equal to 0. N equal to 0 for k equal to 2. N equal to 0. P also equal to 0. Therefore, Z equal to no encirclement. N equal to 0. N equal to 0. P also equal to 0. P means what? Number of open loop holes on the right hand side. That is 0 because what is given? The given open loop transformation S plus 2 and S plus 3. That is poles are minus 2 and minus 3. That is in the left hand side. Therefore, P equal to 0. No encirclement because it intersect before minus 1. It intersect before minus 1. Therefore, at minus 0.4. That's why it is not encircling minus 1, n equal to 0. Therefore, Z equal to n plus P, that is equal to 0 plus 0 equal to 0. Therefore, the given system is stable. What is second part in this question? Find the range of K for the system to be stable. Find the range of K for the system to be stable. We know that if you increase K, its size will increase. the plot size will increase. That's why as k increases, this point will move to -1. 0.4 will come here as k increases. How much k we have to increase? What is the factor by which this 0.4? 0.4 when k equal to what? 0.4 k equal to 2, not k equal to 1. We have to draw to find the range of k. We should plot for k equal to 1. That already I told you. That 0.4 must be divided by 2. That is equal to 0.2. Or if you substitute, instead of 2, if you substitute k, what you will get? In the modulus of this value, instead of 2, if you substitute k, that here what you will get is 0.2k. 0.2k, we have to make it is equal to 1. Then it will pass through that -1. Therefore, k equal to 1 by 0.2. That is equal to 5. 1 by 0.2, that is equal to 5. When k equal to 0, what happens? This point comes here, coincides with the origin. Therefore, k must varies from 0 to 5.